Hi friends, welcome back to this series Understanding Operating Systems One Concept at a Time. We are into our fourth module where we look into how the memory is managed. So let's jump into it. Hi, I am Sandeep, your mentor. Welcome to this series and this session. Memory management. Yes, memory is an integral component of any computing system. Without a memory, nothing works because all the execution of any process has to be done through the memory, which means that the program which you want to run has to be put onto the main memory, and once the program comes onto the main memory, then it is called a process. So for any process to run, it has to be on the main memory, and main memory is indeed limited in size, and we have lot of expectations out of memory. And to make sure that the memory fulfills all our expectations, we need a proper management, proper strategies, and that's what is the next part we are going to look in this series, memory management. So first we start with various strategies we have to manage the memory, look at some background about the system, process management, then the memory, how the memory is managed and all that. And then we know that the resources are limited, the memory is limited in size, but requirements are more. So one way to solve this problem is any given time only one process will be running, because there is only one CPU. In that case, one process can be running. Then instead of keeping all the processes on the memory, we can do is whatever possible those processes, let us get it onto the memory and make sure that they run one after other and so on. And if at all we want to run any process which is not there on the memory, then it has to be brought to the memory. But to bring that into the memory has to be freed, and to free it, then we need to move one process out of the memory so that we can get another in. So this process is called swapping. So we swap out one process which is already there on the memory and then swap in into that place. So how the swapping is done, what are the challenges we have in the swapping, and all that is to be looked in this session. Then we'll have allocating the memory. So the easiest way to allocate a memory is allocate in a contiguous way, that we have a memory beginning from here which is free. So from there you start allocating memory for a process. So whatever amount of memory a process requires, a full contiguous locations of that amount is made available for that process, and that is allotted to that process. And any other process wants, then the next line onwards, or the next position onwards, will be allotted to the next process in a contiguous way. So that way various processes are allotted on the memory one after other, making sure that they all the code is put at one place one after other. So that is contiguous memory allocations. It's a simple to allocate and all that, but it has got some drawbacks, that as the processes come in and go out, then some holes will be created. And when you are trying to fit a new process, and if that hole is not going to fit that process, then you cannot put the process there, because we need complete full size of the memory for that process. So whatever process requires that full size memory is required at one place. We can't put that in chunks and all that. So that's a problem we have, and this is going to create holes and fragmentation problem. So to overcome this, we started thinking about creating a small chunks of memory called pages of fixed size. So whenever a process requires memory, then some number of pages are allocated to that. And now the advantage of working with pages is that these pages need not be in contiguous locations, they can be anywhere. So that makes the effective utilization of the memory possible through paging. Then we need to look at how this paging and all that is managed. So for that we need the page table and all that. Then in the page we do have some additional problem. So there is some problem which we call segmentation. That means inside the page some part of the memory can be left unused, but that can never be used, because if for any process one full page will be allocated, you can't allocate a part of the page for any process. Therefore, even though memory is available in the overall context, but you can say that it is available in small chunks in each page and not useful. Therefore, if I just look at how much memory is free, then it can show me a very big amount. But look at that in detail, you can find that a small part in each page is available. Summing up looks like a big one. So that's what we have, a segmentation problem. Then how to overcome with the segmentation problem, or how to minimize the segmentation problem, is what we have to look at this. Then once we started using the paging system, then we realized that for any given process, number of pages are required for that, and if those number of pages are not available at any given time, then one option is wait for all the full number of pages are available any time and then use that process. Or look at the other side of the process management. We can see that any given time one line of the code will be being executed by the processor, because they have only one processor. So any given time one line is read and one line is executed. So only at some part of the code will be executed any given time. Then it is not necessary that the whole process should be on the memory at any given time. So you can have a small part of the process on the memory, whichever is required. So that way, even if we have a process which requires 100 pages, but even if we have a single page, then we can ensure that this 100-page process can continue executing even using a single page. That means whichever page is under execution now, only that page you put it there and then work on that. Anytime that page work is done, then change that out and get a new page onto that from that process, and that way we can do it. So it appears that even though we are using a single page in physical sense, but virtually a 100-page process is being run. So that is something what we call is virtual memory, and we look into various aspects of virtual memory, how the demand paging works, and when a page is to be added to the system, then we have to remove one page from the system, then which page should be changed. So we have to look at page replacement strategies. So we have various algorithms to replace the pages and all that. We have to look at that. So these are some issues we need to work on when we are talking about the memory management. And looking at the objectives of the module, it is to provide a detailed description of various ways of organizing memory hardware. So it is to discuss various memory management techniques, including paging and segmentation problems. Then the objective is to provide a detailed description of say Intel Pentium, which supports both pure segmentation and segmentation with paging and all that. So these are some objectives we have. And the next session we start into more details of what memory management is. We begin with a simple situation, how a program or a process is available on the memory and how it is used by the processor and all that. So that's the next session is all about. Thank you.